This video is about Cpcfc, which stands for corresponding parts of congruent figures are congruent. So first thing I need to talk about is go into a little bit more depth about Cpcfc. I'm also going to talk about what it's more commonly known as, in case you would like to Google it. Then I'm going to just do a brief general example, an example that shows you how you would use Cpcfc to find new information, what kind of thought process you should be going through, and then I'll walk you through an example proof. So, like I said in the intro, this means corresponding parts of congruent figures are congruent. So this helps us say that if we can establish that two figures are congruent, then you can say that all of the corresponding parts are congruent. It's obvious, but it gets used in proofs in ways that oftentimes kind of mystify students. If you ever want to Google this topic, you should actually Google Cpctc, which the T stands for triangles instead of figures. I decided to use figures instead because it applies to all polygons and not just triangles. But most of the world uses Cpctc. So, if you're asked something along the lines of, is segment A congruent to segment D? Segment AB congruent to segment DE? What we're first going to do is to establish that we have congruent triangles. So looking at this diagram, I should go ahead and mark that I have vertical angles. And then when I look at the diagram a little bit closer, I see that I have angle side angle in both triangles. So yeah, they're congruent by angle side angle congruence. Then, using Cpcfc, I can show that these two sides must be congruent because they're corresponding to each other. So yes, AB is congruent to DE because the triangles are congruent, so all of the corresponding parts are congruent. You might be able to use this from to pull out new information about something. So if we're given that this segment AK is perpendicular to segment JN, or NJ, we want to show that it also bisects the angle up here. So we're not told that we're going to be using Cpcfc. We just need to kind of deduce that, understand that it's part of the process here. So what we have here, two triangles. We know that the triangles share a side. The triangles are right triangles because of this perpendicular part. So why can I say the triangles are congruent? Well, if I just started naming the sides, I would see SSA, which we know we're never going to use. But it's a right triangle, so we can say that the two triangles are congruent. Triangle AJK is congruent to triangle AKN by HL, since they're right triangles. The next part is to use our Cpcfc to show that what we were being asked to prove is true. So if the triangles are congruent, that means these two angles are congruent. So if angle, again, AKJ is congruent to angle AKN, that must mean because of Cpcfc, because bisectors create congruent parts, this must mean that AK is an angle bisector. So to solidify the thought process here, we showed that the two triangles were, well, first thing we need to kind of interpret the question. If we're being asked to show that two things are congruent, it may not be obvious that we're being asked to show things are congruent, because remember that there might be words like bisect involved, which means that congruent parts have been created. We're going to find two triangles in the diagram to help us out. We might need to draw in a new line to help us. We're going to show that they are congruent, and we're going to name the postulate or theorem, and then we use Cpcfc to prove what we are being asked to prove. So for example, if we're told that AK bisects JKN, so we're kind of working backwards from the proof, and that we have an isosceles triangle, alright, well that's already given to us. We're being asked to prove that this part here is perpendicular. So here's my two triangles. The next thing that I'm going to try to do is show that the two triangles are congruent. So I have additional information to add in. I can say now that I have side, angle, side, and it's the same in both, side, angle, side. Okay, I can say that triangle AKJ is congruent to triangle AKN. By this time it's side, angle, side. So then the next thing that we're going to do is show that these two angles are congruent, because if you have two congruent angles on a straight line, they must both be right angles. Alright, so angle JAK is congruent to angle NAK by Cpcfc. Since two congruent angles on a straight line must be right angles, that must mean that AK is perpendicular to JN. I know this is a little bit lengthy, so make sure you just jot down a quick summary about it. You're almost done, so just remember to write down what Cpcfc stands for and what it's used for.